Soft delete in Azure Blob Storage is a protective mechanism that enables administrators to recover data even after it has been removed or overwritten. Rather than permanently erasing a blob or container upon deletion, this feature retains the data for a predetermined period, allowing users to restore it if needed. This aligns with the broader aims of cloud resilience, where data retention policies and backup strategies are essential to meet organizational continuity requirements. By configuring soft delete, businesses can bridge potential gaps in their data protection workflows, especially when used in scenarios where accidental deletion poses a significant risk. Contextually, this concept extends the principles examined in previous modules, such as configuring Azure Storage Networking and setting permissions with SAS tokens, ensuring that administrators can maintain granular control. As part of Azure's overarching storage management framework, Soft Delete creates a more robust environment that can handle both operational errors and compliance-driven mandates. Implementing Soft Delete is vital for scenarios where data loss can have immediate operational or financial consequences. For example, developers might accidentally overwrite a production asset while deploying new versions of an application, risking business continuity. In industries dealing with sensitive information, healthcare, finance, or legal fields, Soft Delete ensures that data can be swiftly retrieved if removed due to human error. Additionally, audit and compliance laws often mandate a specific retention period, making Soft Delete a viable method to meet such requirements. This capability supports a broader protective scheme that includes encryption at rest, network-level firewalls, and advanced recovery techniques. It draws upon earlier improvements in storing business-critical data, where identity-based access and access keys have already established a secure foundation. Soft Delete thereby merges seamlessly with existing Azure storage strategies, offering an extra layer of safety without significantly impacting performance or operational workflows. Before enabling Soft Delete, administrators must confirm that they have contributor or owner access at the storage account level. Legacy approaches, like secured access via tokens, keys, or stored access policies, remain relevant as they govern who can modify settings, create containers, or interact with blobs. The scope of configuration is not limited solely to new data. Existing blobs and containers also come under the Soft Delete umbrella once the feature is activated. However, it is crucial to verify the default retention period and ensure that it aligns with internal archiving policies. For large-scale deployments, existing best practices around redundancy and data replication should be combined with Soft Delete to maintain consistent business resiliency. By satisfying these prerequisites, organizations can integrate Soft Delete with advanced capabilities such as object replication, which was examined previously in the context of cross-region data distribution. When Soft Delete is enabled for blobs, Azure maintains a snapshot-like version of the deleted or overwritten object for a designated time. This retention period starts the moment the deletion occurs. During that window, users with appropriate permissions can restore the blob to its prior location or an alternate location. The metadata, including the deletion timestamp and interaction logs, becomes accessible for auditing purposes. This feature does not disrupt standard read or write operations on existing blobs, meaning system performance remains consistent with an unchanged usage pattern. Furthermore, it fosters an additional safeguard. Even if an individual intentionally or unintentionally removes a blob, administrators can retrieve it to fulfill operational continuity or compliance requirements. The synergy between Soft Delete and existing Azure Storage Explorer or AZ copy usage ensures that data restoration is straightforward through either the portal, scripts, or third-party tooling. Similar to blob-level Soft Delete, container-level Soft Delete retains entire containers, including their underlying blobs, if they are removed. Rather than losing the container's structure and data irreversibly, Azure stores the data in a recoverable state for the configured retention period. This is especially valuable when containers host numerous mission-critical objects organized under a specific storage tier. By recovering the container, teams can restore entire sets of objects without recreating each blob individually. This process aligns well with storage redundancy strategies, such as copying data across primary and secondary regions. Despite providing such robust protection, container-level soft delete respects existing identity and access policies, so only those with the right scope and permissions can manage or recover containers. Consequently, it dovetails effectively with previously introduced features like shared access signatures and firewall configurations. Selecting an appropriate soft delete retention period is a strategic decision that depends on organizational policies, regulatory demands, and resource management. Setting it too short may provide insufficient recovery options, while making it excessively long could lead to increased storage costs. Many organizations align this time frame with their internal data lifecycle policies, similar to how they choose asynchronous replicas or backup schedules. Defining the retention period also affects the separation of responsibilities within a storage environment. For example, compliance officers might request a minimum period to fulfill legal guidelines, while developers might need a quick undo mechanism for active projects. In multi-region architectures, you can synchronize or vary these retention settings across different accounts. This approach ensures that each environment addresses local compliance rules and satisfies the prior best practices echoed in your distributed workload designs. Recovering a soft deleted blob typically involves using either the Azure Portal, Azure CLI, or PowerShell, leveraging the retrievable snapshots maintained by the storage service. Administrators can navigate directly in the Azure Portal's storage account blade, where the deleted objects appear with timestamps indicating their removal. By clicking Restore, the blob reverts to its original path. Alternatively, script-based approaches can be employed, which is advantageous for large-scale or automated restoration tasks. During the restoration process, Azure merges the snapshot's data with the appropriate metadata, ensuring that the recovered blob devolves no differences from its original state. This restoration path does not require complicated manual merges, nor does it interfere with ongoing read/write operations. Instead, it seamlessly reintegrates the blob back into the active system. In higher-level workflows, it can complement existing backup solutions or function as an additional fallback for developers deploying frequent changes. When an entire container is soft deleted, its restoration can similarly be managed through the Azure Portal or command line interfaces. In the portal, administrators can locate the container listed under deleted entities, each with a relevant timestamp. Once selected for restore, the container, along with its constituent blobs, is reinstated. This container-level function proves invaluable when multiple objects must be recovered simultaneously, maintaining original folder structures and hierarchy. By contrast, the restore process at the container level can shorten operational recovery times and reduce complexity, especially if an application references multiple blobs distributed within that container. Further, container-based recovery can be combined with other storage account-level features, such as Azure Monitor logs or custom alerting policies, to notify an administrator of abnormal or unintended deletions. In this manner, entire container sets can be protected in alignment with robust data management practices explored in earlier units. Enabling soft delete intersects with existing security models by potentially enlarging the window of data availability. On one hand, this is advantageous since accidental or unauthorized deletions are reversible. However, it also means that an attacker who gains access might attempt to purge data permanently by waiting until the end of the retention period. Hence, it remains crucial to combine soft delete with multi-layer security, such as Azure RBAC roles and firewall restrictions that limit access to the storage endpoints. Administrators should also configure logging and monitoring to track deletion and restoration events, ensuring any suspicious activities are identified promptly. Using stored access policies or identity-based authentication for Azure files can further tighten control over how operations are performed. Ultimately, these layered measures align with best practices covered across the broader scope of Azure storage management, extending the protective environment beyond simple read/write credentials. Given that soft delete events represent significant data lifecycle changes, incorporating them into a logging and monitoring strategy is essential. Azure Monitor and Azure Storage Analytics can capture, delete, and restore operations, providing administrators with insights into who performed these actions and when. This audit trail becomes highly valuable for compliance, especially in regulated industries that require documentation of data handling practices. By correlating these logs with metrics like file access frequency or egress bandwidth, teams can identify trends or potential misuse of the soft delete feature. Alerts can also be configured to inform stakeholders whenever a large-scale container deletion occurs. This layered oversight complements earlier topics, such as setting up firewalls and using advanced data management tools like Azure Storage Explorer. By integrating analytics, organizations ensure that soft delete aligns with broader governance frameworks, where transparency and auditability are a natural part of daily operations. Azure Portal offers a straightforward interface to enable soft delete on blobs and containers. After accessing the desired storage account, navigate to the Data Protection section, where you can toggle the feature on or off. Defining the retention period is similarly intuitive, with a numerical value that can be modified at any time. Once saved, all new and existing containers and blobs in that account are subject to soft delete. The portal also provides real-time feedback, showing how many objects are protected and the current usage trends. For administrators overseeing multiple environments, each storage account must be configured independently, which aligns with the distributed nature of Azure's design. Testing the restoration process can be done immediately by creating a sample blob or container, deleting it, and confirming that it appears in the deleted list. This visual approach complements the script-based methods in Azure CLI, offering a user-friendly method for routine configuration tasks. Environments that demand script automation or that manage large-scale storage deployments benefit greatly from configuring soft delete using Azure CLI or PowerShell. For instance, administrators can run commands like AZ storage blob service properties update with the enable delete retention true parameter followed by delete retention days to set the retention period. Similarly, PowerShell offers commandlets such as set as storage service properties to modify these settings. Script-based configuration supports version control and repeatable deployments, ensuring consistent practices across multiple subscriptions or geographies. Administrators can incorporate this approach into DevOps pipelines, validating each stage of the storage setup. Moreover, one can schedule automated tests to verify if soft delete remains operational over time. By leveraging the same identity-based management principles discussed earlier in access key or role-based assignment modules, these scripts can be run securely without exposing critical credentials. Soft delete can influence storage costs, particularly if large volumes of data remain in a deleted state for the entirety of the retention period. Azure charges for the stored snapshots and container data that linger until the scheduled purge. Consequently, it is advisable to balance data safety requirements with budget constraints. Monitoring can be done by reviewing the storage account's metrics in the Azure portal or by using resource management solutions that aggregate cost analysis across multiple accounts. Additionally, it is prudent to periodically adjust retention durations based on shifting compliance guidelines or operational risk profiles. If certain containers experience frequent deletions, longer retention settings might lead to higher consumption. Conversely, if no accidental deletions have occurred in a given time frame, the organization may lower the retention duration. This approach ensures that resources remain allocated efficiently, aligning with the cost optimization techniques shown in other aspects of the AZ-104 program. When implementing soft delete as part of the overall storage strategy, it is beneficial to combine it with other core Azure features for a complete data protection framework. Leveraging tools like Azure Backup, site recovery services, or cross-region replication can further bolster resilience. In conjunction with identity-based access, administrators retain precise control over who can initiate deletions, even those that are ultimately reversible. For more sensitive data, encryption at rest and in transit remains a prerequisite, ensuring that even recovered deleted items adhere to compliance requirements. Periodic testing of recovery workflows is recommended, simulating accidental deletion or malicious activities to confirm that data can be restored reliably. Documentation of each environment's configuration, including retention periods, helps align teams on the scope of protection in place. Finally, consider the synergy between soft delete and advanced lifecycle management policies to automate transitions between hot, cool, or archive tiers, maintaining a holistic approach to data management across the Azure ecosystem.